Thank you. So my name is Orde, and I'm a consultant who specialises in building device-agnostic websites. There's a write-up of this talk on my website, which is decadecity.net. That includes all the examples, goes into more details, and has links to further resources. So today I'm giving a talk about CSS at a JavaScript conference, which might seem a bit odd. But let's have a quick show of hands. So who here writes CSS? Yeah, that's most of you. Okay. Now who likes writing CSS? Okay, a few of you, yeah. So the difference between the first and the second set of people is why we've got to talk about CSS. So this is pretty much what people think about CSS. In fact, this is the industry standard meme for CSS. So let's have a look at how we get into this situation. We start with the Cascade. It's the C in CSS. So it's the first word of the language name, so it's important. Essentially, the Cascade says that, all other things being equal, the last declaration wins. What this means is that CSS is dependent on source order. The same rules declared in a different order can have different effects. So let's see what this means in practice. So the first case, we have the base class being defined as red, and then we have the alt class defined as green. Both classes are being applied to our element, so the second declaration takes precedence as it's later in the cascade or later in the source order. The second case on the right, we reverse the two rules in the source order, and the effect is also reversed. The markup's the same, the rules are the same, but the order's changed, so the cascade is different and the effect is different. Now, it's fairly easy to understand what's happening here on this example on the screen there, but imagine these rules are hundreds of lines apart in your source code. They may be in different files, coming from different sources, and they're being used in different places across your site. They all end up in the same place. So unless you're actively managing the cascade, your code is going to end up being hard to maintain. And the cascade doesn't just apply to rules, it applies to declarations within rules as well. So we can see in these examples that in the second case, the margin top property isn't going to take effect because it's being overridden by the margin property immediately below it. So this is easier to manage than the rules cascade. Essentially, if we're keeping the number of declarations in our rules to a minimum, we shouldn't run into this. However, we can help ourselves out by choosing a convention for ordering within our rules. What we want to avoid is using some kind of arbitrary sort order, like alphabetical, or even worse, just keep stuffing declarations into the end of the rule as we go along. That's worst case scenario. So if you thought the cascade was bad, then specificity will get you into even more trouble. With the cascade, the last rule in source order applies. With specificity, the rule with the greatest specificity selector applies. Specificity is independent of source order, but if you've got two rules with the same specificity, then the cascade comes back into play and the source order starts applying again. That's a bit of a mouthful. I had to read that off my notes to make sure I got it right, but we'll come on and see what that means in a minute. So, working out the specificity of a selector can seem a bit confusing, but there is logic behind it. The specificity of a selector is expressed as a 4-item matrix, and the highest specificity in the lowest index wins. So, to build the matrix, you break the selector down to its component parts and then add them up. So looking at the table here, we can see the specificity for each type of component. The global selector has no specificity, which makes sense. It's not specific, it applies to everything. Next up we have elements. They are less specific because it applies to every element of that type on a page. Followed by classes. We can have more than one element with a class, so again, getting a bit more specific, but still not specific as IDs. There can be only one ID on a page. And finally, we have inline styles, which we're not using, right? So, see an example of that. Here we have a class and an ID, give us a matrix of 0, 1, 1, 0, and two classes which give us 0, 0, 2, 0. This first selector wins because it has the highest number in the lowest index. The 1 trumps the 2. Now, specificity overrides the cascade. So if you have two rules for the same property declared, then regardless of source order, the one with the higher specificity will take precedence. So in this example, we can see that the additional specificity of the ID means that it's taking effect even when it's earlier in the cascade. And finally, CSS has a single namespace. This means if we're not very careful and disciplined, we are inevitably going to end up with conflicts. And this is pretty much how CSS code bases of any size get out of control. So I'm going to go on to have a look at an example of how this happens. The example is admittedly fairly trivial, but if you've worked with a CSS code base of any size, you'll be familiar with this kind of situation. So, to start with, we have an error presentation that we're using across the site. Fairly simple, errors are red. That's fine. Sometime later, we get a request to change the error presentation on the login page. So we open up DevTools, we inspect the element, and we can see it's got a class of error. That's fine. We change the color from red to orange, and everything looks good. However, there was only one form on the login page, and what we didn't realize was we've now changed errors across the entire site, which is not quite what we wanted to do. So what's happening is our second orange declaration is occurring after the first red declaration, so it's taking precedence in the cascade. So we open up DevTools again, we have a look at the login page and see if there's something else we can work with. Now, turns out there's an ID of login form wrapping the fields, so we can use that to target just the errors in that form. Now, what's happening here is the second declaration uses a more specific selector, so any error contained within that form will be orange, whilst errors outside that form will still be red. Job done. So now we get a request to change the color of error messages on email fields to blue. So we look at it, there's fine, there's a class of email on the email fields, so we can add an additional class to our selector, and now all our email errors are blue and all our other errors are red. Unfortunately, this selector has a lower specificity than the one we previously used to fix the login form. So we can't up the specificity of the email field selector because it's got to apply to all email errors. So what we do is we add an important annotation. Now, the way important works is by resetting the cascade. Effectively, there is now a second cascade of declarations that have the important annotation. So here, email error will now trump the higher specificity selector for the login form because that doesn't have important. So this is pretty much where we've ended up. Right, before we move on to techniques to deal with this situation, I'm just going to quickly cover preprocessors. Preprocessors aren't a technique, they're an authoring tool. Preprocessors make it easier to write CSS, which means they also make it easier to write good CSS, and they make it easier to write bad CSS. So when you first look at preprocessors, it's very tempting to think that you can use them to create namespaces by nesting code. So after all, what we've got there looks a lot like block scope in a curly brace language. However, just because it looks like block scope in a curly brace language doesn't mean it is. The problem with this is the code is going to be processed into that. What we've got here is a lot of specificity and a tight coupling to our markup. So this CSS is going to be fragile and hard to maintain. The important thing with preprocessors is to think about them in terms of the output, not the input. You're still writing CSS that's going to get delivered to the browser. There's no compiler doing optimizations. You're just indirectly writing CSS. So, let's move on to some techniques. As this Cascade specificity bun fight situation is common across projects of pretty much any size, a number of techniques have evolved to deal with it. So let's have a look at a few here. There's SMACS, or Scalable Modular Architecture for CSS. It's an approach that mitigates the worst of this Cascade specificity bun fight. The key principles of SMACS are structured code. You should structure your code in a logical manner to minimize conflicts. One of the big things here is don't just keep shoving stuff in at the bottom of the CSS file. Make sure things have areas of responsibility. Depth of applicability. So if our CSS has too much depth of applicability, then we can't reuse it. So in that previous example with the preprocessed code, that was very tightly coupled to markup. If a presentation is tied to one particular area of your site, then you can't reuse it elsewhere without doing all sorts of horrible crimes against HTML and CSS. And minimum specificity. The easiest way to avoid specificity issues is to always strive to use the minimum practical specificity, which is typically one class. It's better to have several one-class selectors than one several-class selector. Moving on to OOCSS, or Object-Oriented CSS. This is a way of managing your CSS across the site. With OOCSS, we try and extract small reusable elements, or objects, from our visual design. The objects should be really minimal, so you can combine them in different ways to form the basic UI elements of your site. So here's an example of an element we're using on our site. It's a box with some content, a JavaScript image on the left, and a border. It's in the top right of the slide there. We've split this out into a panel object that handles the layout and a border object that deals, surprisingly enough, with the border. So here we're combining these two to get the layout and the border. But we can use this layout independent of the border, and we can use the border independent of this layout. So we can reuse these elements across our site without having to duplicate what we're writing each time. Now the key to OOCSS is to keep the objects small and reusable. You're probably not going to have too many objects defined, at least you're hopefully not going to have too many objects defined, but they are going to form the basic scaffolding of your visual presentations. This is what's common to everything across your site. So we know we want to keep our specificity low, ideally to one class, and we don't want to couple our CSS to our markup. So OOCSS is good providing the basics, but we're going to run into the limits of it quite quickly. For more complex presentations, we can't just keep on piling more objects onto everything. That's also going to be unmaintainable in a different way. So when we get into the detail of individual presentations, we're going to use BEM, which is Block Element Modifier. BEM is how we get around the twin problem of a single namespace and low specificity. We essentially use a naming convention. We break our code into logical blocks, which will often match modular components in our UI. A block is the top-level wrapping element of our module. Now, because we're going to need to style different parts of our block, we want to keep specificity low, so we're not nesting things, we're going to use elements to refer to the individual parts. The class name of an element will consist of the block name, followed by a double underscore, and then the element name. Finally, we might need to have different variants of a block or element, and for this we use a modifier which is prefixed with a double hyphen. So here's what this looks like in practice in your CSS code. So you notice here that all these selectors have a specificity of one class, which is what we're aiming for. So let's see what it looks like with some slightly less abstract class names. So these are some classes we might use for a read more presentation that has a title, which when you click on it, expands and exposes a content area, sometimes known as accordions, different names for the same thing. At the top level, we have our block. In this case, we've imaginatively called it read more. So that's the wrap around the component as a whole. Within that, we have a title and content expander elements. Now, it's probable that title is going to be used as the name of an element in several different places throughout our site for different components. So if we just use title on its own as a class name for that, we are exposing ourselves to namespace conflicts. However, the name of a block is going to be unique, so it means that the name of an element within a block is also going to be unique. So read more is unique, so therefore read more title is also unique. Now, our content expander is going to need two states, open and closed. So this is where we use modifiers. Again, if we just added an extra class of open or closed to it, then we're exposing ourselves to namespace clashes because something else might well have a class of open and a class of closed. So here, we've got low specificity on each of these. They're only one class. If we tried to do the same thing by nesting, we'd have a specificity of 3 classes and the possibility of namespace clashes. So we've got the dual benefits of avoiding conflicts and we're keeping our specificity low. So this is the JavaScript slide. It's a JavaScript conference, had to do something. So we can create additional problems for ourselves with JavaScript bindings. When we bind JavaScript functionality to the UI, it's really tempting to use the presentational classes because they're already there. Problem with this is you've now coupled your functionality to your presentation. So to avoid this, we use dedicated hooks. So 2 common approaches, either prefix classes with .js, it's pretty obvious what that one's all about, or use data attributes. Both approaches have advantages and disadvantages. People can get quite fanatical about them, but basically work out which one works best for you, pick one, stick to it. So by using dedicated hooks to bind your JavaScript, it means you can move and reuse functionality without having to move and reuse the associated visual presentations. So taking the example of the read more expander we had before, if we tied the expand collapse functionality to the title, it would mean if we wanted to add an additional trigger, then we'd be refactoring both the CSS and the JavaScript. However, if we've got a dedicated hook for the JavaScript functionality, we can just move that around without affecting the visuals. So, to sum up, the key to tolerating CSS is to understand how Cascade and Specificity interact with each other within the single namespace. Once you understand how all 3 affect each other, you can start to write your code in a more consistent, understandable, and ultimately maintainable fashion. Thank you.